In this lab, we are going to be getting user input, which will be of integers, and then we are going to take those integers and associate a score with them. And then at the end of our program, we are going to add up this score because we are prompting the user for multiple inputs. And then depending on what that score is, we're going to output something. There's going to be two different possibilities. So if our score is higher than a number, it will output something. And if it is lower than a certain number, it'll output something else. So this will be using basically if-else statements and scan integers for user input. The first thing that we're going to do is start the title. So we're going to have a few comments here, and these comments are just going to be talking about our lab. So first we're going to have the title, which is lab3.s, and then we're going to have our name, and then we'll leave a space here and then give instructions of how to assemble it and load it. So we'll do assemble, and then we have as-o, and then we need to assemble first our .o file. So it's going to be lab3.o and then lab3.asm. After this, we need to link it to any other files that we have. So we're going to just call this link, and in here we're going to have ld for link that, -o, and then we need to link it to a.out so we can print it, and then of course lab3.o, and then csc35.o, which is the library you're going to be using for this. Then we need to just execute this, and to execute this, all we're going to have is a /a.out, and this will run when we get out of this compiler here. So to start our data section, we need to use .intel_syntax with no prefix, and this means that we're going to be in the Intel syntax. There should not be a space between no and prefix, and then since this is our data section, we're just going to call this .data. Now we can start writing our titles, and these are titles that are given to us, or they're prompts, and they're labels given to us in the rubric for this project. This is what we're going to put in our .data section. So these are all of our labels. The first is title, which is this part, and then we have two /ends so that we can have two spaces. And then we have a /0 to end this, and then we have another label here, and then another label here, another one here, here, and here. And these are basically just prompts asking the user for input. So we're going to use a scan int to get their input, and then we are going to do something in our .text section based off of their input. And then these are also in our title part. They're going to be labels that come up at the end, which is going to help us output the final part of our code. Next, we're going to be in our .text section to handle everything that we've done here so far. So we're going to start this by doing a .text, and then we need to do a .global_start to make it global, and then we'll do _start, and so now we can start typing. So the first thing that we are going to do is print out our title. So we're just going to do lea rax, title, and what this is doing is it's calling the title, storing it inside of rax, and then we can use print cstring to print it out. After this, we are going to need to print out question 0 right here, and this is asking for books, and now start writing it. So we're going to do lea rax and then question 0 because we're printing out, or we're storing question 0 in rax, and then printing out with the call print cstring just like we did with the title. And now we have this option right here. Did we buy our books? Yes or no? Well, if we have no for this, this is basically going to increment the amount of stress that we have. So for every student, if the answer is not done or it's not correct, we're going to add stress points. And that's what we're going to be comparing later on in our code. So if we are not stressed, if it's asking us did we buy our books and we already have our books, we are going to skip on to this next question. If not, we need to add a certain score here, and for this score it'll be 25. So what we can do first is do a call scan int. That way we can scan the integer for the input that the user is going to write, and then after this we are going to have our compare. We are going to compare this to 1, so we'll compare RAX comma 1, and then we need to see if this is equal to 1. So we're comparing RAX to 1, and RAX is going to be whatever is inputted. So we're going to do jump equals, and then if we jump equal, we're going to jump to the next title. So we can make a new title below this. We're going to call our next title something that has to do with what we're going to be doing. And our next question is, do we get an animal pet? So we're going to just call this pet. And the reason why this is commented out here is because we don't really need this title. I'm just doing it right here for consistency and because it makes the blocks look nicer. So we have pet. And if what we get is equal to 1, that means the student is not stressed. So we're going to jump equals to pet. However, if our student is stressed, that means we're not going to jump over pet. Instead of jumping over pet, we are going to have to add 25. And we're going to do this in the register RBX. So we'll add 25 into RBX. So what this is doing is it's printing out our prompt, it's getting the user input, it's storing it in RAX, and then comparing it to 1. If it's equal to, because this is jump equals, if it's equal to 1, we're going to jump to pet. And then we're going to skip this. If it's not equal to, we're going to fall through this, and then we are going to execute this, adding 25 into RBX, and then go on to pet. And this is basically going to be the same thing, where we have Leia RAX, we're printing out question 1, and then we're going to call print cstring to print it out, and then we need to call scan int to get the user input, which is an integer. And then for this question, it says, did you get an animal pet? If it's yes, that means we're not stressed, so we're going to compare our RAX to 1, and if it's not stressed, we're going to jump equals, and then we can call this next label house, since it has to do with what house you'll be sorted into. So we're going to say jump equals house, and if this is right, or if we're not stressed, we're going to jump into house, which is our next part. Now if we are stressed, we're going to add into RBX the value of 10. So previously we added 25 in here if we are stressed, and now we're just going to add 10 to it. So if both of these are stressed, it's going to be 35. We're just adding into RBX, and this just adds in the current value overwriting the previous value. So in house, we need to do the same thing where we have Leia, which is load effective address, RAX, and we're loading question 2 into RAX. Then we're going to call print cstring to print it out, and then call scan int to pick up user input, and then we need to compare RAX, and what we're comparing it to depends on the question. So looking at the house, are you afraid of what house you get sorted into? Well, if the user input's 1, that means they are afraid, so they are stressed. So if we compare this to 2, and then for here we do jump equals, and then we're going to move on to the next question. The next question is Muggle born, so we'll just call this Muggle, and jump here if they are not stressed. If they are stressed, we're just going to add into RBX 10. This should actually be 30 instead of 10, so if they're all stressed, we are going to get the value of 65. From here we have Muggle, and what we're going to do is do a Leia RAX, which is loading the effective address of question 3 into RAX. Then we're going to call a print cstring to print it out, and then call scan int to get user input. And then for this question, if we are Muggle born, we're going to put yes, that means we're stressed, so we're going to compare this to 2, and 2 would mean that we're not stressed. So we're going to compare RAX to 2, and if it's 2, we're just going to jump to the next part, and the next part is having to do with wands. So we'll call this label wand. So we'll say jump equals wand. So if RAX is equal to 2, we're going to jump to wand. If it's not equal to 2, we're going to be under here, where we add into RBX the value of 15. And these numbers can be changed to whatever. I'm just using these, and they're all going to add up to 100 stress points when they're done. For wand, we are just going to print wand out, which is our question 4. We're going to load our question 4 into REX, and then we are going to call print C string to print it out, calling scanint to get that value, and then we need to compare this to, or we need to compare our RAX value to whatever the stress part is. And for this one is, did you get your wand? If you're not stressed, you're going to put yes. So we're going to do 1 here. This means they are not stressed. And then from here, we're going to say jump equals. In this next part, we're going to print out our total, which is your stress level is at, after this wand part. But we need to call it a different label. So what we're going to do is we're going to call this stress, and we're going to jump to stress if we're greater than 1. We need to go to stress anyways, but basically if we are stressed, we need to add into RBX before we get there. So we just have stress here, but before we get into stressed, if we are stressed, we need to add into RBX the value of 20. For our stress, we need to call the total. So we're going to do load effective address into REX, the total. We need to call print C string, and if we go back up to our total, which is what we are printing out right here, we're printing the total. If we go back up to this label right here, we're saying our total stress level is at, and then all we need to do is output all of the RBXs that we've added up. So if we go down here, we just need to move RBX into RAX and then print that in. So we're going to move into RAX the value that's stored in RBX. And then after this, we are going to call print int. And this will print this integer. Now, we need to see if the stress level is high or low. And we're going to compare this to 70. So in our statement right here, we'll say compare to 70, and this is just a comment. This is not a label or anything. So in our compare to 70, if we go back up here, we're going to say that if we're greater than 70, then we're going to print this out, that we're so stressed. And then if we're less than or equal to 70, we're just going to print out this calm statement. So if we go down here, once we finish this stress part, we're just going to go through here. So what we need to do is first compare our RAX, which currently stores whatever our stress level is. We're going to compare RAX to 70. If it is greater than 70, we're going to jump to our statement. So we'll say jump greater than, which is JG, and we're going to jump to, and we'll call this stressed. This will be our label for here. In stressed, we are just going to print out what we need to. We're going to say Leia RAX, where we print out Coco or Coca, and this is basically this string right here, this label that holds this string. Our C needs to be capitalized. We also need to call the print C string, and then after this label, we're going to end our program. So we always need to end our program eventually. So we're going to call end program. And so after we, if we are stressed, we are just going to jump to the stress part, and it's going to print all of this out and then fall through and end the program. Now, if we aren't stressed, we are not going to jump to stressed. We're actually going to print out a statement in here. And what we need to do is do a Leia RAX, where we just call whatever our calm is. It's titled calm, so we're just going to call calm, and then we need to do a call print C string to print this out. After we print this out, we want to skip over this. So what we can do is put our call end program in a label like this, and inside of here we can just do a jump to the end. and this is going to jump regardless. There's no real like parameter in here. Once it hits this jump, it's going to skip over stressed and go straight to end because we have the label jump in here. If we wanted to, inside of here, just for consistency, we can write jump end as well. That way we specifically know it's going to go into the end. So this is going to be our dot text section, but this is the last part, and then we have part up here, which is our, well, we have the rest of our dot text section, then we have our dot data section, and then we also have description for it right here. So now we've gone out of our Nano workbench by doing Control X, entering Y to save it, and we are back to assemble, link, and execute our program. So to do this, we're going to do as-o and then lab3.o and lab3.asm. I have some errors in here, so we are going to go back inside of our code and see what they are. We have a warning that we're missing a 0 assumed and an error for the number of operands matching JG, which is jump greater, and then we have an invalid character, and these are all, it seems to be near the end. So I actually found my first error, and it is right here, and it is after load effective address. So that should be like this. So I found my other issue, and it is similar here. While we have these labels and they follow with a colon, when we actually jump to those labels, when we have a jump right here, we don't need the colon right here, and I accidentally did that in this line. I have jump greater than, and I have stressed with a colon. So if we do a delete and get rid of this colon, this should fix our issue. It's because I did not spell end program right. So we have to call end program, and then we can try to assemble this. The assembly works. We're going to link it. The linking works, and now we just need to test this. So we'll do ./a.out, and this will execute it. So we have this here. So we're going to test, do 1, 2, 1, 2, 1, and this should give us the output of 40, and since it is less than 70, we are doing fine. We have no stress. If we were to clear this and do an a.out to run it again, and we did 2, 1, 1, 2, 2, we see that our stress level is at 75, and it prints out the stressed part. So our code works perfectly, and it gives us the correct answer.